Hello. In a previous video, we talked about creating a task such as this. We named it our basic movement versus animation task, and we talked about creating this program, basically modeling how to move a sprite across the screen and back again, a basic movement, and also animate a sprite as well by using the next costume feature. The main purpose of that program, besides animating, was to be able to focus on the grade 4 level Ontario math curriculum expectation. And just to show you quickly what we are talking about with that. So right now I flipped over to a screenshot, and if I take a look at the grade 4 column, there are two specific expectations related to the algebra strand of the math curriculum. And with the last video, we basically created code. We were creating a mathematical situation by writing and executing code with the focus on nested events. So for this activity now, we are going to take the same activity that was created, but now we are going to focus on altering existing code and then being able to describe how changes to that code affected the outcomes. So let me just switch back over to my Scratch window. So what would happen in this situation is we are sharing a link. We are making the sample activity available and providing a link that will be available to all staff members within our system. So if they access the link, this will take them to this activity, and the idea will be, you can see that there are some basic instructions. Step 1 and Step 2 were included in Part 1 of the activity, which again was a previous video. For today's activity, we are going to focus on Step 3, and this is just an example. We are going to alter the existing code. Now, I've given a prompt here. One way that you could possibly alter the existing code is by creating a race between the two penguins. I'm just going to click the green flag here quickly just to run the program so you can see what the original version looked like. So you can see that the penguin at the very top of the screen is using a basic movement, moving to the right side of the screen and then back to the left, whereas the penguin on the bottom of the screen is doing a full animation. You can see it actually doing some movements, which was created by using the next costume coding block. Again, that was all part of the previous video. So now the idea would be, as part of the other specific expectation in the math curriculum for coding, is take this existing code and make changes to it to alter the outcomes. Now there are a couple of different steps before I show you how this can be done. A couple of considerations when we talk about altering existing code. One of them is if there is an issue with the code, something that a student is possibly looking at where they are saying, this is not working the way that I think it should be working, and it needs to be fixed. If it's something that needs to be fixed in the code, we call that debugging the existing code. If it's something where a student simply wants to change the code and make an alteration just to basically change the way that the program will run, it's not necessarily fixing a problem, it's just changing it to make it run differently. That's a basic enhancement or alteration of the program. So a couple of different ways to approach this from the student perspective. So the students would access this possible link. If they have their own accounts in Scratch while they are signed in with their username, they will access a shared activity such as this one, and they will have access to the green remix button. So the idea would be for the students to click remix. Once they do that, this project automatically becomes saved to their account where they are able to make changes. They now have a program that they can use to make alterations to an existing code, and it becomes their own program. Any changes that they make at this point in no way impact the original version of the program that was created by the original user. So right now, I'm going to pretend hypothetically that I am now a student in the classroom and I have accessed this code. So the teacher's given me a prompt. Here's the code. What alterations or changes can I make to this code? So if one of the things I want to do when I play this is clearly not a race. These are two penguins that are moving across the screen at the same speed, at the same time, and arriving at the end at the exact same time. The first thing I might take a look at and say, well, one of the penguins is not animating. The top penguin is just moving across the screen without its fins and its legs moving. So that's the first change I can make to the code. That's one change. So I'm just going to fix that one very quickly. That is penguin 1 that I need to change. If I switch to penguin 2, I can see in my code. And again, if you are looking at this program for the first time without having the benefit of seeing our previous video, A lot of this is not going to make a whole lot of sense to you, so we would always recommend watching the videos in the proper sequence, but whatever works for you. So in this code, you can see that I have used a next costume block in my repeat loop. This will allow this penguin to animate. The other penguin right here does not have a next costume block. So assuming that this is a lesson that has already been pre-taught to the students, then there's some context for it for the students to recognize I need a next costume block that I need to put in my repeat loop. Now, once I do that, I now have both of my sprites moving across the screen that are animating. And again, just a quick review, when I say sprites, I'm talking about the characters in Scratch of which we are actually coding. So these penguins are the two sprites in this program. So that's one problem that's fixed. The other problem is that if I'm trying to alter existing code, and for this example, I'm trying to create a race, I fixed the animation problem, but I still haven't created a race. I'm looking at this as a student and thinking, how can I use the code available to me to randomly choose, or I shouldn't even say choose, to be able to click the green flag and not know from one race to the next which one of these two penguins is going to make it to the end and back first. So again, this is something where if it's not pre-taught, there will be some exploration on behalf of the students going through these different colored options, all of these different control blocks here, to be able to see which coding options are available. If these lessons have been pre-taught, then the students will have seen that if they go down to the green operators button, there is a button that says, or a coding block that says pick random. That pick random block is going to be an essential part of altering this existing code to be able to create a racing situation. So instead of repeating, when I'm saying repeat 65 times, and I'm moving 6 steps and I'm waiting 0.02 seconds, I could, instead of knowing how many steps I'm taking, maybe I want to choose a random number of steps between 1 and 10. I can set these numbers as high or low as I would like to. And maybe my wait time that will control the speed of which the penguin is moving. Maybe I want that to also be a random time. So right now, if I just make those two little adjustments, instead of having a pre-selected number of steps and a pre-selected wait time to control the speed of the penguin, I'm using a random selection, so I have no idea how quick this penguin is going to move. Now I click the green flag. And I only have one penguin moving. Penguin number 1 is not moving. So I have to take a look and I have to ask myself, why is that? What is wrong with my code? So again, it gives me something else now. So I'm making changes to my code and something is not working. So let me just take those random pieces out and let me run that code again. There we go. I still have not solved the problem of it being a race. So again, this is one of those things where we have that judgment call as educators in the classroom. How much assistance, how much scaffolding are we going to be giving the students? So right now, I'm still looking at this as a student and thinking, okay, why is this not working if I use a random in here? Maybe if I just put it in the move, random 1 to 10 steps. Let's take a look. And you can see now that I have one penguin that is inching ahead, and I now have a race situation where they are not moving at the exact same speed. So the penguin on the bottom is in the lead right now. They reverse, and it looks like it's going to be very close. And again, a slight win to the penguin that's on the bottom. So that's just one example. So I've made one small change to the code. I could also change the number of repeats. I could come over to penguin 2. I could change it from 6 to 15 steps. So again, as a student, I'm exploring the code, experimenting with a variety of different changes, because the goal is to find out what is going to happen with my program every single time I make these changes. I'm altering the existing code. Now I click the green flag, and we have a significantly unfair race where penguin 2 is winning by a long shot because of the increased number of steps. Now, there's a problem right now in the code. So every time I make a change, I'm introducing the possibility of there being another problem. So right now you can see that suddenly the penguins are not turning and coming back the other way, whereas they were before. So again, why is that problem happening? So as a student, I'm making changes to the code, I am experimenting, I'm always prepared to have a conversation with my teacher saying, well, I've changed the move steps. So with the greater number of steps, that means the penguin is moving faster than the penguin that's only moving 6 steps at a time. So again, it's that conversation piece, being able to talk about the changes that are being made. You might notice that I have another section right here where I say when the green flag is clicked, forever if touching edge, then stop all. So this is something that's more of a grade 5 level expectation, where it's the introduction of conditional statements, which would be the if then. If something happens, then an occurrence is going to happen within the program. So in this code, because I've moved an increased number of steps, what we would be looking for the student to realize, this penguin has moved 15 steps 65 times rather than 6 steps 65 times. This penguin is going to move a further distance because of that. Because they moved a further distance, they hit the edge of the screen. In my code, I have a conditional statement saying that if I touch the edge of the screen, stop all. So literally this program has functioned the way that it should because I am hitting the edge and stopping the program. If I broke that apart and got rid of that, as soon as I remove this from the green flag, I'm breaking the code. Now if I run the program, you can see that there was a bit of a bug. They're going off the page because the penguins are moving too far. So again, as the student now, I don't want the penguin to move off the page. Therefore, what do I need to adjust? I need to come back here and take another look at my number of steps, possibly the number of repeats. What can I do to alter my existing code? So the idea is not to make this a long and complicated video. It's just to give you a quick example of how that second expectation, just flipping back here as a grade 4 example, reading and altering existing code, and then being able to describe how changes to the code affect the outcomes. This is one example of an activity where the students are able to access a program that has already been created. They're not creating the entire program from the very beginning. They already have access to it, but they are challenged to make changes to that program to either fix mistakes or bugs in the program or make their own unique alterations and then be prepared to talk about those changes with the teacher. So again, I hope this has been helpful for you. Thank you.